We've seen how to grow a network to some intermediate size, but we are also well aware that such growth comes with several disadvantages. Adding a new switch for each LAN is a very manual process that doesn't scale well. So what's a better option? Instead of using 3 physical switches to support 3 LANs, we can create a number of virtual LANs even on a single switch. Virtual LANs, or VLANs for short, logically segment a switch into distinct local area networks. Logical segmentation uses software, as opposed to hardware, to separate individual devices into separate networks. Here, we have 7 hosts connected to the switch. We virtualize the switch segments such that hosts 1 through 3 are on VLAN 1, hosts 4 and 5 are on VLAN 2, and hosts 6 and 7 are on VLAN 3. Each of these VLANs is its own subnet, with its own broadcast domain, even though they are all sharing a single physical switch. The switch accomplishes this logical segmentation by associating each of its ports with the appropriate VLAN. So, how do virtual LANs make scaling easier for us? Let's take a look. If an additional host needs to be added to VLAN 1, a second switch can be added using a trunk link. Then, if an additional host needs to be added to VLAN 3, the same switch can be used. Scaling virtual networks is as simple as assigning or reassigning ports to the appropriate VLAN. Suppose that 3 switches are needed. Note that the trunk links between these switches are carrying traffic from multiple VLANs. As a result, these trunk links must run an encapsulation protocol between switches to identify which VLAN a frame belongs to. For traffic that travels between different switches, a switch will encapsulate the frame with a VLAN ID. When the next switch receives the frame, it will decapsulate the packet and use the ID to determine where to send the frame next. So now there are a number of physical hosts spread across 3 logical networks. At this time, traffic is limited to its host network. What if we'd like to add virtualized workloads and allow inter-network traffic? Let's simplify the example such that we can focus on the workloads. Note that we're simply abstracting the 3 switches into one, but the underlying structure can be much more complex. Each of the 4 physical hosts is running several virtual machines. If we would like to locate these different VMs and different VLANs, how could we do so? To begin with, the link between each physical host and switch will need to be a trunk link to be able to carry traffic from multiple VLANs. Just like in the last example, these trunk links will run an encapsulation protocol. A packet leaving a VM will be encapsulated with the appropriate VLAN ID before leaving the physical host, and then decapsulation occurs at the recipient host. If traffic on a network is limited to just that network, a Layer 2 device would suffice. However, anytime traffic needs to move from one network to another, a Layer 3 device is required. So if we wanted to allow packets to travel from a VM on one network to a VM on another network, the switch here will need to be a Layer 3 switch to handle such inter-VLAN routing.